The human circulatory system is truly a marvel. If you were to take all of the blood vessels out of an adult and lay them in a line, that line would be nearly 100,000 miles long, almost halfway to the moon. The human heart pumps between 1,500 and 2,000 gallons of blood a day. Arteries carry this blood away from the heart, delivering oxygen, vital nutrients, and hormones to tissues throughout the body. In such a complex and vital system, the margin of error is small, and when things go wrong, they can be catastrophic. Atherosclerosis, commonly known as coronary artery disease, is responsible for nearly 20% of all deaths worldwide. This condition is a process in which deposits of fatty material, called plaque, build up inside the walls of arteries, reducing or completely blocking the flow of blood. Although the exact causes of atherosclerosis are not clear, many scientists think it begins with damage to the inner wall of the artery, or the endothelium. Substances traveling in the blood, such as cholesterol, fats, and cellular waste products, accumulate inside the damaged area of the arterial wall. Chemical reactions occurring within the buildup of material cause cholesterol molecules to oxidize. These oxidation reactions initiate an inflammatory response in which the endothelial cells at the damaged site release chemicals that signal for help. In response, monocytes from the bloodstream travel to the damaged site. Stimulation from oxidized cholesterol recruits the monocytes into the extracellular matrix and converts them into macrophages. It is generally believed that once the macrophages arrive in the extracellular matrix, they begin to phagocytize the lipoproteins. They do this to the point of overload and eventual rupture. Because atherosclerosis is primarily an inflammatory disease, cytokines released from the dead and dying macrophages will serve as chemoattractants for additional macrophages. Although less numerous than macrophages, this cocktail of chemokines released via stimulus from interferon gamma will also serve to recruit T lymphocytes to the plaque deposits. As a result of this inflammatory process, the macrophages become laden with cholesterols that become foam cells. These foam cells accumulate over time to form plaques, and as the plaques increase in size, the arterial wall thickens and hardens. At the same time, smooth muscle cells within the arterial walls will begin to multiply. As they multiply, many of these smooth muscle cells migrate to the surface of the plaque. Once these muscle cells reach their destination, they'll weave together to form a cap made of fibrin and collagen. And while this cap shields the blood from the inflammatory reactions happening beneath, eventually the passageway through the artery narrows enough to reduce blood flow and the amount of oxygen received by the organs it supplies. Over time, the cap may erode and break open, releasing plaque into the bloodstream. The plaque can then flow downstream and contribute to the formation of a blood clot. Once the clot has fully occluded the flow of blood, there is no oxygen being delivered to the organs and tissues past the artery. This causes them to become infarcted, and irreparable damage can set in within 20 minutes. And while atherosclerosis can occur in any artery, you are likely most familiar with it occurring in the arteries that supply blood and oxygen to the heart. This is known as a myocardial infarction, or heart attack. The risk of developing atherosclerosis relies heavily on genetics, but there are many environmental and behavioral factors that contribute as well. Smoking causes not only hypertension and stress to blood vessels, but the rate at which arterial occlusion occurs in smokers is 2 times faster than in non-smokers. Obesity and poor diet is another major contributing factor to the development of atherosclerotic heart disease.